Switching gears to another topic, we've had several changes in the networking part of the system. One new feature that landed in this release that was done by NVIDIA Mellanox is the ability to offload IPsec. So if you've been around some of our talks over the last 2 years, we've talked a bit about kernel TLS offload, where we do the bulk crypto, either in software inside the kernel, or in some cases, if it's a smart NIC that can do TLS in the NIC, we actually hand the raw data to the NIC, and the NIC encrypts it out on the way onto the wire. This is a similar acceleration for smart NICs, but it's instead of dealing with IPsec. So it allows the NIC to deal with encrypting and decrypting IPsec inside the NIC itself instead of doing it on the host CPU. And this is currently supported by NVIDIA Mellanox ConnectX 6 cards in 15.0. Another change we had in the networking stack is a lot of bits around the Unix domain socket system were refactored and improved. It was kind of special case in many cases to be separate and not kind of reusing some of the same socket layer code that, for example, TCP uses, but to have more dedicated and optimized routines. And the result of that has been improved performance, both with lower latency and better throughput on Unix domain sockets. So moving off of the network and onto other things, over in the file systems area, we've had a couple of different changes. One thing I know that I've talked about because I worked on it a fair bit is we now support NVMe over fabrics using the TCP transport in 15, both the controller, which is kind of the client side, or the target side rather, and the host side. So you can attach to remote namespaces and they show up like a local disk. And you can also export arbitrary block devices or files or RAM memory disks as a remote namespace to remote hosts. Another change that's kind of a little more user-facing, and something that actually folks in our ports side of the project have been asking for many years, is we've added an implementation of the iNotify system call for kind of monitoring parts of your file system to learn about events and changes happening in your file system as an event stream. We've had the ability to do some of this through K-Event before with vnode filters, but iNotify makes some different trade-offs, and for many use cases, it can be both more efficient but also more reliable. There's some race conditions around discovering new files that are kind of inherently unavoidable inside K-Event that iNotify fully solves. And also, iNotify is just used in some very commonly used software such as desktop stacks, things like KDE and so forth. So this really improves some of the user experience and kind of simplifies some of the porting efforts for that type of code. Some things that are not quite neutral to architectures, but instead architecture specific. We had a new framework land to support something called CPU tracing. This is not quite the same thing as performance counters that count events, but instead CPU tracing is a way to get a journal or a log of different things happening on a CPU while it is executing a stream of instructions. So for example, you can trace like a sequence of what branches are taking and maybe some metadata about the branches that are taken. So we have the framework that was added for this, as well as the kind of architecture-specific backends for several different instantiations of this on hardware, including CoreSight on ARM, and then I believe the successor to that, SPE on ARM, as well as the processor trace extension on Intel processors. Another change that landed in 15 is support for AMD's version of IOMMU. This is useful for in Beehive, we already kind of have an internal driver for this that you might use for PCI pass-through, but there's another use case that's kind of more common now for IOMMUs, besides just protecting DMA. On modern x86 systems, the original APIC ID is limited to 8 bits, which it turns out is not very big in our modern world of having lots of core machines. And several years ago, Intel and AMD together redefined how we talk about APIC IDs and how they are larger. But in our interrupt controllers, we were still restricted to only having 8-bit IDs. And so an IOMMU allows, one of the things it can do is to have a remapping table to translate the interrupt descriptor entries inside of IO APICs or inside of MSI messages and translate them from small 8-bit APIC IDs to the larger APIC IDs to handle large core count systems. And we've had support for this for a while for the Intel's version of an IOMMU, something called the DMA remapping table. And in 15.0, we've added the AMD version of that as well, which makes the support for large core count AMD machines more seamless out of the box. Along with things we've done inside the tree, we've also been actively updating various things that we import from the outside world, so trying to stay up to date with our third-party vendor code. And this includes a wide variety of things, but I'm going to highlight a couple here. 15.0 is going to ship with Clang 19, so a fairly recent version of Clang. We've also changed the version of OpenSSL that we are shipping in this release. 14.0 shipped with OpenSSL 3.0, but 3.0 is going out of support during 15.x's timeframe. So we have moved to OpenSSL's most recent long-term support release 3.5, and that's what we'll ship in 15.0. 3.5, well, I did the major version. I didn't do the minor version. Colin is correcting me that my detail is not quite there. We're following the 3.5 branch and whatever the most recent release of that is. For OpenSSH, similarly, we are running, I believe, the most recent, almost the most recent version, but we are keeping up to date. And with OpenZFS, we are running, it's currently a release candidate of their newest version, and we will track this major branch inside of Stable 15 as well. So we are keeping up to date with OpenZFS and many of our big third-party software. Another change we made that is not just keeping up to date with kind of an existing version, but switching streams, is for a long time we've had a version of Kerberos in the tree that came from a project called Heimdall, and we've not been but so diligent about maintaining that version. We were kind of several versions behind what their latest release is, and in 15.0 we've switched Kerberos implementations, and we're now shipping the Kerberos implementation from MIT as our default Kerberos, and it is now their current supported version as well. That's it for that slide. Another change we made that's related to our third-party software is in earlier releases, as we've slowly been migrating our toolchain, which has been a project for many years now. Originally, many years ago, we used a GNU toolchain because that's what existed. And with the advent of LLVM, we've been able to migrate to a BSD licensed toolchain in our base system. And one of the places, while we had done this for big things, like your compiler and your linker, there's also several other bits that come along with a toolchain. Several utilities that do various things, in particular allowing you to inspect and examine ELF files or perform other tasks that are perhaps more arcane or more unusual. Many of these tools are listed on the slide here. And as over time, we've retired using the GNU versions of them, but we were using different various vendor versions of them. We had ELF Toolchain, which was a project to re-implement several of these tools that existed, in particular when LLVM didn't have implementation of many of these tools. And so we've been using ELF Toolchain versions of many of these tools for several years. But in the meantime, LLVM has gained more compatibility with the command line interface of the GNU tools, and has also fleshed out their collection of these tools. And in FreeBSD 15, we are now switching to use LLVM's version of all these tools by default. Besides reducing our dependence on yet another upstream and kind of consolidating where we're getting our toolchain bits from, one advantage of using LLVM's bits for this is that in order to use link time optimization at LLVM, you need to use LLVM's full toolchains kind of end to end, because it's only LLVM's versions of these tools that understand kind of the way LLVM decides to encode the information it needs to do LTO. So with this in place, now LTO can work out of the box on FreeBSD 15 systems. Yes. Here, are you going to run the mic?
Yeah. So I don't know anything about the specifics, but I have been funding a fair amount of work in LLVM to help the Linux kernel prevent a whole class of like memory bugs and problems and stuff like that. Are you guys using those more advanced features? Can I connect you to people who do?
Is this the Hacks project, or?
I don't think I could tell you the answer. Case Cook is leading the effort from Google, but like, there's. Yeah, I think so. I just want to make sure that the dots are connected here, because there's just a relentless push to have new capabilities in LLVM to make a whole class of nasty problems less likely or harder to happen. There's a bunch of work in the kernel, Linux kernel, to make the code actually compile properly with those settings on a module-by-module basis. But since you're making that move, it would be really wonderful to see that effort connected. So that's all.
Sure. So when it comes to using sanitizers, we do support various of the sanitizers to differing degrees of maturity on different architectures. So certainly on x86, 64-bit x86 and 64-bit ARM, we support several sanitizers, and we have existing kernel configs that you can build with them, particular for address sanitizer. I think also msan and the concurrency sanitizer, although I think recently I saw a comment from Mark that the concurrency sanitizer is a bit wishy-washy or a bit buggy in its implementation, and so not the most, it has some bugs in the things it can detect or not detect.
On this, sorry, I cannot see you.
Sure.
Yeah.
Oh, okay.
Hey, John.
I got you, Mac.
Thanks for interesting presentation. On this end, I'm not really opposing it, more like advocate diablo kind of thing. This will open the whole can of worm for third-party people building stuff on FreeBSD if you do this, because usually if it's LLVM obj dump, it's supposed to be like third-party packages expect it to be GNU obj dump, for example. The same for runlib. It's already pretty bad with FreeBSD because we use different hyphen, you know, Linux uses not without hyphen or something. So it's already pretty bad if you want to support both FreeBSD and Linux building. But with this one, it will make it a whole lot harder for people, because then you need to find out if it's GNU kind of tool or LLVM kind of tool, and right now it's just by name.
Well,
Yeah.
so you're still able to install GNU binutils from ports if you wish to use the GNU binutils, which quite frankly sometimes I do, because I find things in LLVM's readout that aren't quite there yet compared to GNU's readout. Particularly dumping things like dwarf, I find the GNU tool still more readable. But LLVM is getting increasingly better. Even things that did not work as well for me several years ago, LLVM now does. No, we can't do that because the build system needs to name the tools by name.
I'm sorry, this is total nonsense.
Brooks has entered the chat.
We have not had GNU tools under these names for over a decade. Like, the LLVM ones are moving, and they care about compatibility with GNU ones much more than the ELF toolchain stuff, which is just dead. I mean, it's hosted on SourceForge in Subversion. Like, seriously.
The ELF toolchain originally and the LLVM tools now aim for GNU compatibility. We did an XBrun, a ports XBrun, prior to switching the default, and there was not a lot of fallout. I think that broadly speaking, the total number of issues is kind of equivalent from ELF toolchain versus GNU and LLVM versus GNU. And I'll give David one quick comment. But
yeah, this is going to be the last one because we still have things to cover.
I can come back after.
Okay, right, we can do questions at the end.
We'll put a pin in that one.
I want to give Ed's laptop a chance to catch fire, and if we ask too many questions now, we're not going to get to that. So let's see, what's the next one? Oh, it came up. Okay. So one nifty feature, by the way, that was a recent addition in the last few months, is traditionally in Unix systems, when something went wrong in a system call and you got back an error, the only thing you got was an integer, your error no. And half the time you got back E and val for 47 different conditions, and you had no idea what that means. Good luck. You can start to use dtrace or something to try to figure out which place you got E and val from, but there's really not much hope without adding some explicit tracing or doing something unpleasant. So we've added a new thing, or really Constantine has added a new thing to the kernel to support extended error status. An extended error status is effectively we can save some state with the current thread to log additional details anytime we're going to return an error. And we save whatever the most recent kind of logged additional information is. And there's a special system call that you can call or you can query. It's either that or it's a shared memory location. I can't remember which. But effectively, after every system call, you can get this detailed information to print out, to contain more information about your error and what went wrong. Inside the kernel, we have a new macro, xerr, that you can insert anytime you want to return an error no value, and you put the error no value as the first argument, and this nice little string that gives more details about what the error was as your other argument. And along with that, it also logs some other details, such as which line number the error actually happened on. inside the source file. Then we have a couple of places in the space system that already know about this for you. So if you use the error API, like the functions like error or warn or errx or so forth, they already know about this special feature. And if you call them and it's a situation where a system call logged one of these additional error messages, it will dump it to the console for you. You don't have to change anything in your application code. It just magically happens. And we also have a new trace point and ktrace and kdump that you can use to access this information when you're debugging. So here we have an example. I pulled this from one of the QUIA tests that tests an invalid thing of mmap, where it's trying to test that you passed an incorrect set of permissions, like some invalid permission. It's not one of prompt read or prompt write to mmap. And if you call error in that case to report the error, traditionally, you would just got an invalid argument, but now you get these extra bits in parentheses where it tells you there's an extended error, and you get the string that came from inside the kernel of those unknown prompt bits that you passed in. So it gives you a little more detail about which argument to mmap was invalid, as opposed to one of the 8 arguments was invalid. And then if you were to run this under ktrace and you use kdump to log it, you get to see the same thing. In this case, there's a few more details. You can see which source line it was on. And one of the features actually of the in-kernel macro is that you can pass 2 optional arguments that can be pointers or integers, and those show up as the P1 and P2 arguments in the ktrace output. So this can be a useful way that you can annotate errors inside the system to provide more debugging information about what's going wrong in a system call, while not breaking the normal default C API for system calls in Unix systems, or POSIX systems at least. So I think that's the last thing we have on the slides. Now we're going to have the fun part. I'm going to let Ed set his laptop on fire.
Now we'll see what explodes.
Actually, I just need one or you just to be physically close. It's like the Wim field, but the Warner field.
That only worked if I had a shoe and was going to hit it. I can do that.
No, that's OK. Please keep your shoes on. The people sitting around you will appreciate that.
You're not wrong.
All right, so do you want to narrate, Ed?
Yeah, I will narrate and do this. Let me just see if I can get this to go away. No. All right, well, the sidebar will stay.
So first, what is this Silv thing? This doesn't say FreeBSD on it. So do you want to explain this a bit more?
So I'm going to use Silv to run the demo. This is a project that we received in the foundation received as a project proposal that's been underway for a while now. And this is a Beehive and jail manager. So it's a web-based manager for VMs as well as jails. So this is a in-progress snapshot. I'm not sure exactly which version is running here. There's no release of this yet, but it's this is running from a snapshot from GitHub from not too long ago. And so we will. Let me just get my notes over here.
So this is like the status of the current host machine. Is that correct? Like your laptop?
So this is running on a rented host
okay.
at Hester. And it's like a 8-core machine, I believe. And so it has a lot of sort of nice affordances built in this utilities menu here. It's got a little tool that will download ISO images and store them locally for creating new VMs. So I fetched 14.3 last night. And so what we're going to do is go over here where it will create a new volume for our demo. We'll make it 20 gigs. And everything else, I guess, is good. And now we can say create a VM. leave that as the default. Put it on the Summit demo. Oh, that's not the one I created. Demo Summit, there we go. And we'll use virt.io. We'll use virt.io for the network as well. And we'll make it 2 cores. So now we have our new VM here. We start it. Oh, it's not working. Oh, I didn't.
Did you not point it at ISO?
I didn't point it at the.
This is why we do live demos, because
Yeah.
then it's more fun.
I ran through this demo several times, and when I wasn't doing it live, I remembered all the steps.
That's OK. We'll see how few steps it takes to add an ISO image to the boot. And think about how many characters on the command line we'd have to type instead. So you asked about adding ISO to a running VM. I do know, who was I talking to? Boyan was talking to me a few weeks ago about injecting hot plug events for devices, which would allow you, among other things, to inject storage. In particular, that's probably more useful to inject the NVMe storage. But that is something that he is actively working on. I think in theory, we have a control socket to Beehive now that Beehive Cuddle can use to send messages. And more or less, it's an issue of adding new message types and forward them across. One of the things that Boyan is running into that makes it a little more challenging is with Beehive being capsicumized, you have to do a bit more work over on your utility side to actually open file descriptors and so forth that you then pass across the Unix domain socket to the Beehive process itself, which means you use slightly different paths, for example, to initialize a device than you do. And so teasing that apart requires some work.
All right. I'm just going to create it
Just
again.
to make a new one? Oh my gosh.
Run through my my steps that I actually.
You can call this one Demo 4.
Sure, demo 4.
That was a joke. I can make bad jokes all day. You really should do NVMe. It's going to be faster than virt.io. 14.3? Yeah. Do you want to do 2 or 3?
Let's try 14.2.
OK. What can go right? Huzzah! All the ASCII art that we love.
So I'm just going to do a hit enter a couple of times, install. My intent here is that we'll get this VM created and then switch it to package base and show what.
And upgrade
what
using
goes there.
package base?
Yeah.
And you haven't typed a single thing on the command line yet.
That's correct.
So now if you want to ask questions about toolchains, we can do that while we wait for the install to go. Or other topics. Actually, do we have a third mic? All right, we can. I'll run it back and forth.
Since we're dogpiling on LLVM, I thought I'd bring up an issue that happened to us in 14. And what are the thoughts for FreeBSD 15 on, in stable, allowing huge jumps in the version of the toolchain in a, quote, stable version? Currently, 14.3 is running Clang 19. If I recall correctly, we launched with Clang 14.
Or 15, something like
And
that,
4.1,
yes.
and you know each new version complains about more things in code. So as a commercial user, when you think you got a stable desktop platform,
I mean, if you want to keep shipping bugs, yes, you can stay on the old compiler.
they have point bug fixes.
Point bug fixes last about 5 months.
Anyway, the bugs that you know,
Yep.
the bugs you work on. If
So-
you're that concerned, you can go install the package.
The bigger issue is that if you want a stable tool chain in the stable tree, we need to cut the lifetime by at least 2, probably 3 years, because we cannot maintain the port system with a dead compiler. We tried it. It did not. The end of 10 was a total disaster. The end of 12 was pretty bad. We can't not move forward.
And is that true with the current LLVM, and then why are you telling me then that LLVM is so unable to compile things? I mean, there was a time when Stable 14 had a newer compiler in it than at least the 15 snapshots.
No, that's.
Version higher.
David is asserting that if 1.14 had a higher compiler than 15, that's not true. That's not the way the merges work. Well, maybe if we weren't building the 15 snapshots for some reason. But it's always merged to 15 first before 14 in Git. All right, so where are we at on, I see console things. Any other questions about things? Here, I see Colin's got a question. I'll make my camera operator chase me around.
There was a period, I'm thinking around May through July, when 15.x snapshots were breaking pretty much every week due to a combination of issues in the ports tree and, mostly issues in the ports tree.
Yes.
So yes, it is quite likely that for some time the latest snapshot that successfully built in 14 was newer than the latest snapshot that successfully built in 15. Even though I don't think there's any time when the compiler that was in the source tree for 14 was newer than the compiler in the source tree for 15. But yes, we had issues with snapshots not building.
My issue isn't so much that 15 was further behind. It's the move in.
So I have an upgrade question, since we're talking about 15, and it sounds like there's some upgrade things. In 14, I remember there was a situation about needing to update the bootloader, and I'm one of those weirdos from the old days that used to upgrade version to version to version to version to version. But there was a bug, 279829. I just had to look it up because it was driving me nuts. And basically it was talking about having to manually update the bootloader. Basically, you'd upgrade from, I think it was like 14. I see some smiles. People must know what I'm talking about.
Well, we know about the problem you're talking
yeah.
about. Warner's about to jump out of his chair.
Okay, so I'm just wondering.
Just ask the question and
okay,
go run over to Warner.
My question was, is the automatic bootloader update going to happen, or is that something we still have to do ourselves?
The short answer, I think, is this is not fixed. Does Warner want to comment any further about how sucky a problem it is? It will happen. Will happen. All right, I'm going to take the Warner. I'm not going to say your words for you. When will happen?
I'm not going to comment on that. No, it should happen soon. And now that
Soon's
we've got
a very vague word. Soon can be...
soon's better than maybe I'll tell you when and later. But you're right. So right now, most of the systems in the fleet have transitioned to having the ESP mounted on boot ESP. And now that we have that, we can start playing around with automation opt in at first, but later opt out. That will start to update those. So if you have that mounted while you do an install world or an install kernel, I'm not sure which, or maybe a new install loader, it will update it. How this meshes with package base, nobody has probably thought about that till I mentioned it right now. So we'll need to figure that out. So during the life of 15, we'll solve this problem to give us a slightly less vague answer, which is sometime in the next 2 years.
I think we'll aim to solve the problem for the simple case that you have a single ESP that you've mounted.
Right.
We may not promise to solve the problem for
that we should,
more complicated cases.
Yeah, for that we should have something sooner than that. Part of the problem is I don't know how much extra time I have to work on this because it's not something that's a business critical need for my employer. So that's why I'm hedging a little right now. Also, my boss is in the room, so it makes it harder to do stuff. But it is a problem. We do need to deal with it soon, and it's easier now than it was a couple of years ago when we started on this journey.
All right, I think I'm going to hand it back to Ed, and I'll come back to Simon.
We'll come back to
done your next demo.
We'll come back to the toolchain discussion in just a moment. So I have now fetched the package basify script from the Foundation's GitHub account. This is a tool that has been shared
for root, right?
Of course, has been shared for converting an existing system to package base. This is all kind of a little bit experimental and unvetted at the moment, but it's a proof of concept.
Don't worry, just running this root on your system, it's all fine.
So it's going to ask us if we want to create a boot environment before it starts. And so now it's fetching 14.2 packages for the base system. Hopefully this works. My previous attempt was with 14.3, so hopefully this works. We can take questions on this as we're going. Colin also has lots of package-based experience and can comment as well.
So we're installing 370 packages. Is there a canonical document that gives guidance on the granularity of packages and, is this number fairly stable? Could it decrease by quite a bit, increase by quite a bit?
I mean, the source tree is a living thing. We add and remove things from the source tree on a somewhat frequent basis. One could say hourly basis. And sometimes you add things to the source tree that result in a new package, and sometimes you remove things from the source tree that delete a package.
But I was speaking to guidance of the vision, the architecture.
Yeah, I'm not the right person to give you a detailed answer to that. I think we are still, again, this is a technology preview in 15.0. I'm choosing my words carefully, that there are some things one learns by experience, and we are aiming to gain a lot of experience and learn many lessons.
But since 16 Bay Alpha 1 is presumably less than 2 years away, if 16.0 is
it's about 2 years away. That's plenty of time to learn lessons. We're learning a lot of lessons over the last 6 months.
I was wondering if there's something a little more concrete given it's only 2 years out. Anyway, just a question.
There's not currently anything concrete, no. That doesn't mean that there will not exist in the future. I think there's some consensus around what maybe should be in such a document, but it is not yet written in stone. I mean, by default, I think if you add a new library, it becomes a new package, which means you get like 3 packages, because man pages are distinct from debug symbols, are distinct from like the runtime library, are distinct from the headers, and things like that. Part of the trickiness actually is not that trivial thing. Part of the trickiness is when to group. When does grouping make sense, I think, and that is part of the harder to reason about problem, and not necessarily, and one that requires a human to think about it. Okay, we'll go for it, Brooks. I can remember the mic. What I do need to do is check my chime, check my time.
Okay. I've not been terribly involved in this, the package-based stuff, but seeing people working on it online, like on IRC and talking about it, a lot of it's, we started with one set of things in one use case, and now we have other use cases. People are trying to do jail construction or OCI image construction, and that's leading to trying to sort of feel out how we're going to put it all together. And also, we do, in some cases, we do things that made sense as a monolithic system that now we have to sort of break them apart a bit to make things just make sense. And so I think there's a lot of just feeling our way through it, trying to understand how to serve all these different use cases, and maybe someday we'll have a whole philosophy to go with it.
So where are we? Okay, so it's up. Oh, yes, you need the mic. Sorry. I thought you were trying to get me out of the way of the screen.
So we've rebooted now into 14.2, but using packages. So you can see what's here. And then if we want to do an upgrade, our intent is that FreeBSD update will act as a front end and manage package behind the scenes to perform the upgrade, although that's all sort of in progress and being experimented with right now. But for the sake of the demo, I'll just show using package directly to install.
Well, we're perhaps at the end of our time slot. So what we may do is we may allow the demo to run during the break, and we have a break until 2:45. So I will let Ed keep typing away, and we can leave up the slides on the stream perhaps so we can watch the progress as it goes. But if folks wish to go ahead and take a break and run and fetch a snack or use the facilities, go ahead, and we'll get to our next talk by 2:45.
I'm just going to throw my question in. When Warner mentioned ESP a second ago, I was going to ask, are we supporting multiple ESPs?
I think that's the hard problem that we are not aiming to solve out of the box.
Okay, so because I was just going to comment that on one of our EFI-based platforms, what we do during upgrade is we will automatically update the primary ESP. And if we successfully reboot, we'll then update the backup
secondary,
one.
Yeah, I gotcha.
The installer just recently got the ability to do multiple ESPs. So it's an evolving technology. That's probably an excellent strategy. I like that. It's very boot once-ish.
So I've just changed the config file to point it at 14.3 instead, and if all goes according to plan here, we should be able to, if I can type. So it tells us it's going to upgrade 370 packages. And we'll say go ahead. And now it'll fetch the 14.3 packages, and then we'll reboot, and hopefully it will
not catch fire.
Come back up properly.
All right. Well, thank you, Ed. We'll keep watching the screen. Why don't we get